Orangepip Segments is a self-assembly kit that lets you make an Arduino Uno compatible board. The kit contains a PCB and all the components required to make a microcontroller that's functionally identical to the ever-popular Arduino Uno. By building one of these, rather than using one of the ready-made boards, you get to learn how to identify components, hone your soldering skills, and at the end of it, you've got a microcontroller that you can use in any of your electronics projects. Let's give one a build. So now my Orangepip Segments is built, I need to try it in a project. I'm going to build a really simple little robot chassis using some continuous rotation servos, and it's the easiest way to get movement without using a motor driver board, because I can just use the PWM out of this to drive them directly. The other thing I'm going to put on it is a Pixie 2. So this is one of the coolest sensors I've come across for Arduino. It's basically a camera, but it's got a load of stuff behind the scenes. It's got a microprocessor on there that's dealing with all sorts of information. You can teach it color signatures. So that's basically an object color for it to track, but you can also teach it much more, like color codes, or you can use it for line tracking, so it can identify junctions in a line and this kind of thing. So we're just going to use it to track a single color object. And by putting this on my robot, it's going to feed a whole bunch of data back, so what objects it can see and the location in its field of view of that object. I'm going to feed that back to my Arduino, play with that data a bit, control the motors on the servos, and try and build a simple object tracking robot. So I'm going to teach my Pixie Cam a color signature of this orange ball. So I'm just going to show it the ball and identify the color of that object. It will then return data to my Orangepip based on the location of that ball in the field of view of the camera. So as the ball moves away, it moves nearer to the top of the field of view, and the robot should move towards it. If it moves out of the left of the field of view, then the robot will track left to follow it, and if it moves out the right of the field of view, it'll track right to follow it. Now the code's pretty basic, doesn't do anything particularly clever, so it might be a little bit jerky, but hopefully it will demonstrate the principle.